Hello everyone, my name is Calculas. I am pursuing BTech first year in SRIT in CSC B section. Today my topic is about the chain rule of partial differentiation. Moving forward to first slide, the chain rule of partial differentiation. Partial differentiation can quickly get complex, especially when dealing with multiple variables. The chain rule is a powerful tool that makes this process easier and more accessible. Moving forward to next slide. What is chain rule? Definition. The chain rule is a method of finding the derivative of a composite function of two or more functions by relating it to the derivatives of its consistent parts. Explanation. The chain rule is a fundamental concept in calculus used to calculate the derivative of a composition of functions. It is used when differentiating functions in which one function is nested inside another. Importance in partial differentiation. The chain rule is particularly important in partial differentiation, allowing us to calculate the partial derivative of a function with respect to variable that itself a function of other variable. Moving forward to next slide, the general formula of a chain rule. Single variable case. If g of x and f of g of x are differential functions of x, then f of g of x whole dash f dash of g of x g dash of x. Multiple variable case. If x1, x2, and so on xn are variable and each x is a differentiable function of a variable t1, t2 and so on tm, and f is a functional derivation function of x1, x2, and so on xn. Chain rule in higher dimensions. In higher dimensions, the chain rule becomes more complex, but the same general principle applies. It allows us to analyze the behavior of a complex function by breaking it down into simple parts. Moving forward to next slide, applications of the chain rule. Finance and economics. The chain rule can be used to calculate the elastic of demand function, which measure the responsiveness of a demand to change in price. Physics and engineering. The chain rule is used extensively in physics and engineering to analyze complex systems, including electric circuits, fluid dynamics, and thermodynamics. Computer science and machine learning. The chain rule is used to back propagation algorithms in machine learning, which is used to train artificial neural networks. Moving forward to next slide, examples of chain rule applications. Problem statement. Suppose we have a function f of x comma y, g of x into 2 plus y of it into 2, where g is differentiable function. What is the value of dou f by dou x? Solution. We can use the chain rule to find the partial derivative of f with respect to x, treating y as a constant. Dou f by dou x equals to 2 into x g dash x into 2 plus y into 2. The question given for me is if u equals to f r comma s comma t, where r equals to x by y, s equals to y by z, t equals to z by x, show that x dy by dx plus y dy by dx plus z dy by dx equals to 0. Given u equals to f of r comma s comma t, u equals to f of x by z comma y by z comma z by x. Also given x equals to x by y, s equals to y by t, t equals to z by x. Dou u by dou x equals to dou u by dou r by dou x plus dou u by dou s by dou x plus dou u by dou x, dou u by dou x. Dou u by dou x, dou u by dou x of dou u by dou x plus dou u by dou x of x by y plus dou u by dou x into dou u by dou x equals to dou u by dou x into dou u by dou x plus dou u by dou x into 0 plus dou u by dou x of minus z by x2. Dou u by dou x equals to dou u by dou x of 1 by y minus dou u by dou x of z by x2. Now differentiate with respect to y. Dou u by dou x equals to dou u by dou x into dou u by dou x plus dou u by dou x into dou u by dou x plus dou u by dou x into dou u by dou x equals to dou u by dou x into dou u by dou x of x by y plus dou u by dou x into dou u by dou x of y by x plus dou u by dou x into dou u by dou x of z by x equals to dou u by dou x of minus x by y2 plus dou u by dou x of 1 by x plus dou u by dou x of 0 equals to dou u by dou x into 1 by x minus dou u by dou x into x by y2. Now we have to differentiate with respect to x. Dou u by dou x equals to dou u by dou x into dou u by dou x plus dou u by dou x into dou u by dou x plus dou u by dou x into dou u by dou x. Into next step, dou u by dou x into 0 plus dou u by dou x into minus y by x z2 plus dou u by dou x into y by x and equals to dou u by dou x into y by x2 plus dou u by dou x into 1 by x. After doing the simplification, you can get x dou u by dou x plus y dou u by dou x plus z dou u by dou x equals to 0. Hence proved. Moving forward to next slide, the benefits of learning the chain rule. Simplicity. The chain rule is a simple and elegant way to handle complex partial differentiation problems. Versatility. It can be applied to wide variety of fields from physics and engineering to finance and economics. Power. The chain rule allows us to break down complex problems into simpler pieces, giving us greater insight into their behavior. Here we can conclude that the chain rule is a powerful method for calculating partial derivatives of composite functions involving multiple variables and nested functions. Applications. The chain rule has many applications in a range of fields including finance, physics, engineering, and computer science engineering. Thank you. Have a nice day.